In section 9.2, we'll be graphing equations in the form of y equals ax squared plus bx plus c. So basically we'll be taking the equations that we were factoring in the last chapter and now graphing them. So we're still working with quadratic equations, which means that the highest power is 2. So first we'll look at this key concept diagram. It says the properties of the graph of a quadratic function. The graph of y equals ax squared plus bx plus c is a parabola, just like before. Anything that has the highest power of 2 is going to be a parabola since it is a quadratic equation. It is going to open upward. So this way, if the a value, the number in front of the x squared term, is greater than 0, and it'll open downward, so upside down u, if a is less than 0. So basically, if there's a negative sign out here for your a value, it's going to be upside down, reflected. It is narrower than the graph of y equals x squared, so there is your parent function. If a, the absolute value of a, is greater than 1, just like we talked about in the last section, so it's that vertical stretch that we were talking about, and wider if the absolute value of a is less than 1, so like a fraction, again, just like we were talking about in the last section. So again, that is called a vertical compression. So if your a value is a number bigger than 1, it'll get stretched, it'll get skinnier, and if your a value is a number between 0 and 1, then it gets fatter, a vertical compression. It has an axis of symmetry, so again, that's the line that you could divide your parabola up into two parts and fold the one part on top of the other, and the two parts would match up. So the axis of symmetry can be found by taking x equals negative b over 2a. So the opposite of b, the way I like to think about it, is the opposite of b over 2a. And make sure you have this written down in your notes, that if you have x equals negative b over 2a, that really just means the opposite of b over 2a. So for example, if your b value is 3, I would have negative 3 over 2a. If your b value was negative 12, this said minus 12x, then I would say positive 12 over 2a for the axis of symmetry. Also note that this is an equation because the axis of symmetry is a vertical line, so think of VUX, vertical undefined x equals. So the axis of symmetry should be written as an equation, x equals the negative b over 2a. The vertex is always on the axis of symmetry. So if you're looking for the x value of the vertex, after you find your axis of symmetry by doing negative b over 2a, that value is your x value of the vertex. So once you know that the x value of the vertex is found by doing the negative b over 2a, you would take that number and plug it back into your equation and find the corresponding y value. So you find the axis of symmetry by doing negative b over 2a, and you find the x coordinate of your vertex by doing negative b over 2a. Your graph has a y-intercept of the c value. So whatever this value is out here will tell you where your graph hits the y-axis, because if I were to plug 0 in for x here and here, these terms would drop out. And remember, any point along the y-axis has an x value of 0. So again, if I take that 0 and plug it in for my x's, these terms would cancel out, leaving me with just that c value. So again, the c value is where your graph will hit the y-axis. So let's put all of this to work. Here's example number 1. Consider the function y equals 3x squared plus 12x minus 8. So here we have an equation for a quadratic function in the ax squared plus bx plus c form. So to find the axis of symmetry, we are going to take that equation, x equals negative b over 2a. So my a value is 3, the number in front of the x squared. My b value is 12, the number in front of x, and my c value is negative 8. So I'm just going to take these numbers and plug it into my x equals negative b over 2a equation. So I would have x equals, remember, think of this as the opposite of b, so the opposite of 12 is negative 12, over 2 times 3. Now, when we've done this in the past, again, kids get too reliant on their calculators. They type in negative 12 divided by 2 times 3 in their calculator, and they don't get the right answer because you need to take 2 times 3 first and then take negative 12 divided by that. So again, if you type this into your calculator without thinking about the order of operations, we will get the wrong number. So again, rely on your magnificent brain. So we have negative 12 over 6, which would give me x equals negative 2. Again, it has to be x equals because the axis of symmetry is a line, so we need to write it as an equation of a line. So don't forget your x equals. For the vertex, remember, your vertex lies on the axis of symmetry. So the x value, since it's x equals, is the x value of your vertex. So we already know that the x value is negative 2. Now we just need to find the corresponding y value. So if we know that x equals negative 2, we're going to take that negative 2 and plug it in for the x's in our equation. So we would have y equals 3 times negative 2 squared plus 12 times negative 2 minus 8. So once again, make sure you follow the order of operations. So we're going to do the exponents first. So we have 3 times 4 plus 12 times negative 2 minus 8. Now we're going to multiply. So that would be 3 times 4 is 12. 12 times negative 2 is negative 24 minus 8. So then we're going to subtract all the way across. So 12 minus 24 would be negative 12. And negative 12 minus 8 is negative 20. So our vertex would be negative 2, negative 20. So again, find the axis of symmetry doing x equals negative b over 2a. Once you know what that value is, that is the x coordinate of your vertex. Take that number, plug it in for the x in your equation, and find the corresponding y value. The majority of your homework will ask you to graph these quadratic functions. For every graph, I want you to at first identify the following 5 things. The first thing that I want you to identify and write is whether your graph is going to open up or down. And remember, that is determinant upon what your A value is. If your A value is positive, it'll open up. If your A value is negative, it'll open down. The second thing I want you to identify is the axis of symmetry, which remember is found by using the equation x equals the opposite of b over 2a. The third thing you need to identify is the vertex, but just as a quick reminder, once you know what the axis of symmetry is, that is the x value for your vertex, so then all it would take is to take that x value to substitute it back into your original equation and find the corresponding y value. And then the fourth thing that you need to identify is the y-intercept. So what that means is you're going to substitute 0 in for x, but also remember that it is the c value of your quadratic function. And then the fifth thing you need to do is make your t-chart, which we will get to when we do our examples. So just like in the last section where we did the t-chart from negative 2 to positive 2, the same thing. So again, the 5 things would be determine whether it's going to open up or down, find the axis of symmetry, find the vertex, and then identify the y-intercept. And then the fifth thing is your t-chart, just like in the last section. So let's see an example. We have example number 2. We're going to graph y equals 2x squared minus 8x plus 7. So the first thing we need to do is determine whether it's going to open up or down. Since our a value is positive, we know that our graph is going to open upward. So we're going to have a parabola that looks like this. The second thing we need to find is the axis of symmetry. So the a dot o dot s. We do that by doing negative b over 2a, which remember is an equation of a line. So we have x equals. Our a value is 2. Our b value is negative 8. And our c value is 7. So to do negative b over 2a, we do the opposite of b, which is positive 8, divided by 2 times 2. Again, don't type that into your calculator. Just use your awesome brain and figure out that that's 8 divided by 4, which is 2. So our axis of symmetry is at 2. So what I want you to do then is to go to your graph and draw a dotted line showing that we know our parabola is going to straddle that line. So it's going to be something like this. Next, the third thing to find is the vertex. Remember, once you have the axis of symmetry, you have the x value of your vertex. So we know the x value is 2 since we know the vertex is going to lie on this axis of symmetry. So every x value on this axis of symmetry is going to have an x value of 2. So if x equals 2, I'm going to take the 2 and substitute in 2 for the x values in our equation. So it would be y equals 2 times 2 squared minus 8 times 2 plus 7. So again, just use the order of operations to figure out what this is. And in doing so, I got y equals -1. So our vertex would be at 2, -1. And then our y-intercept is the fourth thing that we need to find, which remember is just your c value. So in this case, our y-intercept would be at 0, 7. So we know that we can plot these points. So our vertex is at 2, -1, so I would go over to my graph and go over 2 and down 1. And we also know that the graph is going to hit the y-axis at 0, 7. So we're going to go on the y-axis and count up 7 units. Also knowing that a parabola is symmetrical on both sides, if this point is 2 units to the left of the axis of symmetry, then we know we're going to have another point 2 units to the right. So we can put a point right here as well. And the fifth thing we're going to do is to complete the t-chart. But we're going to do the t-chart just slightly different from last time. The last time we went from -2 to +2. This time we're going to consider that our vertex is no longer at 0, 0 or anywhere on the y-axis like it was before. So we're going to start with the vertex in the middle here. And we're going to go 2 units above it and 2 units below it. So we would go 1 and 0, and then 3 and 4. So you go 2 above the vertex, 2 below the vertex. And then we'll just take these x values, plug them in for x in our original equation, and find the corresponding y values. We can also cut some corners here by knowing that our quadratic equations are symmetrical. We also already know that at 0, we had a y value of 7 from the y-intercept. So we know that this would be 0, 7, which means that since it was 2 units above the vertex, we're going to go 2 units below it. And so at 4, we would be at 7 just like we thought before when we graphed this point right here. So really, all I have to do is find the corresponding y values for 1 and 3. But once I know what 1 is, I'll also know what 3 is. So by plugging 1 in, 1 squared is 1. 2 times 1 is 2, minus 8 times 1 is -8, so I have 2 minus 8, which is -6, plus 7 is 1. So if it's 1 here, knowing that, again, our parabola is symmetrical, since it is 1 unit to the left of 2, 3 is 1 unit to the right of 2, so it will also be 1 right there. So now all we're going to do is take those coordinates and plot them. So the only ones that we haven't plotted yet are the 1, 1 and the 3, 1. So 1, 1 would be right here, so to the right 1 and up 1. And then we, like I said, also know that we are 1 unit to the left of the axis of symmetry, so we're going to go 1 unit to the right of the axis of symmetry and get that point right there. Just like we thought, it was 3, 1 here, so to the right 3 and up 1. So you can cut some corners here just by using symmetry to find corresponding numbers to the left and to the right of your vertex. So to complete our graph now, we'll do one continuous smooth line connecting these 5 points to make our parabola. And there we have the graph of the parabola that represents y equals 2x squared minus 8x plus 7. Let's do one more example. So here's example number 3. It says graph y equals -x squared minus 10x minus 21. So following our 5 steps, the first thing we're supposed to identify is whether the graph is going to open up or down. Since our a value is negative, that means that our graph is going to be upside down. So it's going to look like a parabola, like an upside down U. Our second step is to find the axis of symmetry. We do that by doing x equals -b over 2a. So our a value would be -1, since there would be technically a -1 in front of your x squared term. Our b value would be -10, and our c value is -21. So our axis of symmetry would be at -b over 2a. So the opposite of -10 is +10. over 2 times negative 1. So again, don't use your calculator. 2 times negative 1 is negative 2. So we get x equals negative 5. So our axis of symmetry is the line x equals negative 5. So we're going to go to our graph and count over 1, 2, 3, 4, 5 units and draw a dotted line for the axis of symmetry. And remember, this axis of symmetry will be very useful later when we go to graph our parabola, knowing that if we have, for example, a point 2 units to the left of the axis of symmetry, I know I have 2 points to the right of the axis of symmetry. So let's move forward. Our next step is to identify the vertex. Remember, once you have the x value for your axis of symmetry, you have the x value of your vertex. So our vertex is at negative 5 something. So knowing that it's x equals negative 5, I'm going to take the negative 5 and plug it in for the x in our equation. So it would be y equals negative times negative 5 squared minus 10 times negative 5 minus 21. I can type that into a calculator as long as I'm aware of the order of operations, or I could do this in my head. It's up to you on how you want to do it. Either way that you do it, you'll end up with y equals 4. So our vertex would be at 5, negative 4. So go over to your graph, knowing that your vertex should be somewhere here on your axis of symmetry. So we're going to the left 5, just like we thought, and up 4 units and put a dot for your vertex. So here's our vertex, and now for the fourth step, we're going to identify the y-intercept. Remember, the y-intercept can be found by putting 0 in for x, or just knowing that our c value is the y-intercept. So again, the y-intercept would be 0, negative 21. We won't be able to graph this because that's somewhere way down here. So we're going to have to do a little bit more work when we're doing our t-chart in step 5. So remember, our graph is going to be upside down, so it's going to look something like this. So let's start our t-chart. We'll put it right here. Remember, we're going to do our t-chart taking into consideration our vertex. So our vertex is at negative 5, 4. So we're going to go 2 units above it and 2 units below it. So we would have negative 4 and negative 3. And then negative 6 and negative 7. And remember, whatever your y value is here is the same as the y value down here. And whatever it is here will be the same here because those are the same number of units away from the vertex. Since a parabola is symmetrical, it cuts down on our work. So we're going to take the negative 3 and plug it in for x. Again, you could use your calculator as long as you know you're following the order of operations, or do it in your head. Either way, you'll end up with 0, which means that at negative 7, our y value will also be 0. Next, we'll put negative 4 in for x and figure out y is to get 3. And that also means that the y value at negative 6 is 3. So now we'll just take these ordered pairs and plot them to make our parabola. So the first one we had was negative 3, 0. So I'm going to go to the left 3, 1, 2, 3, and then up 0. So I have a point right there. And since I have a point 2 units to the right of the axis of symmetry, I also know I'm going to have a point 2 units to the left, which would be that negative 7, 0 like we have from our t-chart. Next, I'll plot the negative 4, 3. So I'm going to go to the left 4 and up 3 units and put a point. And just like before, if I have a point 1 unit to the right of the axis of symmetry, I'm also going to have 1 point to the left of the axis of symmetry, which would represent that negative 6, 3 like we have from our t-chart. And then to complete our parabola, we'll take one nice smooth curve and connect those 5 points. And there we have our parabola. So make sure you write down anything you don't understand that we can cover in class. Also make sure you write down the 5 steps that you have to identify while doing these graphs. And of course, whatever we can cover in class to clarify anything, make sure you ask in class. And we'll see you then.